Hi, this is Ms. Rodriguez, your Algebra 2 teacher. This video is for lesson 10-3, all about geometric sequences and series. So let me share my presentation with you, and let's go over these problems. So a geometric sequences, as with arithmetic sequences, which is in the previous lesson, there is a formula for the nth term of the geometric sequence. This formula can be used to determine any term of the sequence. Okay, so this is the formula. A sub n is equal to a sub 1, which is the first term, and then r is the common ratio, and then to the power of n minus 1. Okay, so first you're going to be given a geometric series and then asked to write an equation for the nth term of each geometric series that you're given. So just as a reminder, the formula is a sub n is equal to a sub 1 times the ratio of to the power of n minus 1. Okay, so remember the first a sub 1 is the first term, right? So the first term is right here, negative 2500, okay, times the common ratio. Okay, so we have to figure out what do we do to negative 2500 to get to 2, which is the same thing we do to 2 to get to negative 16. So you can take the second term 2 and divide that by the first term, which is negative 2500, and you just punch that into your calculator, you end up getting negative 8. So the common ratio is negative 8, so we put that in parentheses, to the power of n minus 1. And this equation starts off as a sub n. So it's just asking for the equation, so that's all that we need. Okay? Second example, now here it gives us a sub 3, which is the third term, and then the common ratio. Okay? So if we're given a sub 3, and we know that a sub 3 is equal to a sub 1 times the common ratio of 4 to the power of n, which in this case is 3, minus 1. Okay? And we know a sub 3 is equal to 16, so I'm going to replace that with 16 times a sub 1 to the power of, or times 4 to the power of 2. Okay? And I'm doing this so that I can get the first term, because I'm not given the first term here, but I need it to write my equation. Okay, so then I have 16 is equal to a sub 1 times 16. 4 times 4 is 16. So I would divide both sides by 16, and I get 1 is equal to a sub 1. Okay, so now I have my first term. So when I'm using my equation, a sub n is equal to a sub 1 times the common ratio to the power of n minus 1. So now I have my first term, which is 1. My common ratio, which was given to me originally, is 4. And then it's n to the power of 1. So that is my equation there. So there's an extra step here because we had to find the first term, but we just plug in the information we're given into the same equation, and we're able to isolate a sub 1 and use that to write the equation. So like arithmetic means, geometric means are the terms between two non-consecutive terms of the geometric sequence. The common ratio, r, can be used to find the geometric means. Okay, so it says to find 4 geometric means between 0.5 and 512. So we have 5 tenths, and there are 4 geometric means in between those two terms, okay? Because they are non-consecutive, okay? So what we need to do, we know that the first term, a sub 1 is equal to 5 tenths. That's the first term that was given to us, okay? And we also know that a sub 6, because this is the first term, the second, third, fourth, fifth, this is the sixth term. A sub 6 is equal to 5 tenths which is the first term, times the common ratio, which is what we're looking for. We're calling that r, to the power of n minus 1. So n is 6 minus 1. We know that a sub 6 is 512. And then is equal to 5/10 times the ratio r to the power of 5. So this is an equation. I would divide both sides by 5/10. When I do that, I get 1024 is equal to r to the 5th power. And what I can do is take the 5th root of both sides, punch that into a calculator. The 5th root of 1024 is 4. So now I know that my common ratio is 4. So what does that mean? That means for each term, I multiply the previous term by 4 to get the next term. So my second term, if I multiply 5/10 times 4, then that means my second term is going to be 2. Okay? Then I multiply 2 times 4, and that would give me my third term, which is 8. And then I multiply 8 times 4 to get my fourth term, which is 32. And then one more time, because I need 4 terms, multiply 32 times 4 to get my fifth term, and 32 times 4 is 128. And just to double check, you should multiply 128 by 4, and that's your sixth term, and when you do that, you get 512, which is what we were given here, so we know we are correct. Okay, so these are our missing geometric means there. Okay. All right, then next section, or same section, talks about geometric series, and that is the sum of the terms of a geometric sequence. So the sum of the first n terms of a series is denoted by s sub n, and you can use either of the following formulas to find a partial sum of s sub n of the first n terms of a geometric series. So we're basically going to be using one of these two equations, depending on what information it is that we're given. Okay, so if we're given this example here, it says a sub 1 is equal to 2, n is equal to 10, and r is equal to 3. So since we're given a sub 1, we're not given a sub n, I would use this formula. S sub n is equal to a sub 1 minus a sub 1 times the ratio to the power of n, and this is all over 1 minus r. So then I plug in the information that I'm given. I know a sub 1 is 2, so that's 2 minus 2. My ratio is 3, and n is 10. Okay, so, okay, and then so down here in our denominator, we have 1 minus r, which is 3. Okay, then we can simplify this. S sub n is equal to 2 minus 2, and then 3 to the power of, so 3 to the power of 10, you plug that in to the calculator, you end up getting 59,049, and then 1 minus 3 is negative 2. So I'll just continue this over here. So S sub n is equal to 2 minus 59,049 times 2 is 118,098, and I would still divide by negative 2. So S sub n, I subtract 118,098 from 2, I end up getting negative 118,096 divided by negative 2. So S sub n is equal to 59,048, and that would be my final answer. Okay. Okay, so for this problem, I have a sub 1 is equal to 2,000 and then a sub n. So I can use the other equation here to find the sum of this geometric series. That's the one that says a sub 1 minus a sub n times the common ratio over 1 minus r. And then I plug in the information I'm given. S sub n is equal to a1, which is 2,000, minus a sub n, which is 125, and my common ratio is 1/2, and this is over 1 minus 1/2. So I have S sub n is equal to 2,000 minus 125 times 1/2 is 62.5, and then 1 minus 1/2 is 1/2. So then I would continue this over here. 200 minus 62.5. I'm sorry, 2,000. Whoops, got a 0 there. 2,000 minus 62.5 is 1,937.5 divided by 1/2. So when I divide that, I end up getting 3,875. So that is the sum of my geometric series there. Okay. So it's just a matter of plugging the information that you're given into the correct equation that you have, okay? All right, so then here, you're given this in sigma notation. So what we know to find the sum, we need a sub 1 minus a sub 1 times the common ratio to the power of n, and then 1 minus r. So we need to figure out a sub 1. We need to figure out a sub 1. We need to figure out the common ratio, and then we need to figure out n, okay, in order to use this equation, okay? So first thing we're going to do is figure out a sub 1, okay? And the way we do that is this tells us k is equal to 4, so that first term, k is equal to 4, okay? So we would plug in into this function 1/4 times 3 to the power of k, and we're plugging in 4 for k, minus 1, okay? So we get 1/4 times 3 to the power of 3, and then 3 to the power of 3 is equal to 27. And then 1/4 of 27 is 6 7/500. So now we know the first term is 6 7/500, okay? So then what we need is r, the common ratio. Well, r is equal to the base of the exponential function. So the base here is equal to 3, so that means r is equal to 3. The next thing that we need is the value of n. And the way we figure out n is we take this value here. There's 12 terms. We started with k is equal to 4, so we would subtract 4 and then add 1, and that ends up being 9. So n is equal to 9. So now we have our 3 values here. So we can plug that information back into our equation. So a sub 1 is 6 7/500. Minus 6 7/500. Common ratio is 3 to the power of n, which is 9. So we have s sub n is equal to 6 7/500 minus 6 7/500, and 3 to the power of 9 is 19,683. And we end up multiplying negative 675 thousandths by 19,683, and we end up getting 132,860 and 2,500. Again, you should be doing all this in your calculator. Oh, and I forgot, we're supposed to be dividing by 1 minus r, which is 3. So I have s sub n 6 7/500 minus 132,816 That ends up being negative 132,853.5 divided by negative 2. And then s sub n, when you divide that, ends up being 66,426.75. Okay, and so that is the sum of the geometric series there. Okay. All right, so hopefully this video was helpful to you. If you have any questions, please let me know. You can call, text, or email me, and I'd be happy to help you or to answer any of your questions. Okay, you have a great day, and thanks so much for watching.